Hello students, welcome to Narayana College online classes. In the previous episode we completed exercise level 2 up to question number 25. So remaining questions we will discuss in today's episode. See exercise level 2, page number 51. See question number 26. The unit for molar conductivity. Unit for molar conductivity class. What are the units of molar conductivity? Unit of molar conductivity C1 centimeter square mole inverse. But here C1 is not given, here ohm inverse. How can we write this one? C1 is equal to what? Ohm inverse only. Ohm inverse centimeter square mole inverse only. So C1 is equal to what? C1 is ohm inverse. So what answer we will take? You will see option 1 ohm inverse centimeter square mole inverse. Second option ohm centimeter power minus 2 mole inverse. Third option ohm inverse centimeter square mole inverse. Ohm inverse centimeter square mole inverse. We have two options are there. Option 1 is there and option 3 is there. Option 3 you can change ohm power minus 2, right? Ohm minus 2 centimeter inverse centimeter square. You can say that is centimeter power 2 is there, but here what is there? This is also centimeter square. Okay, you see the options. So one what is the option is given now? Ohm inverse centimeter power minus 2 mole inverse, and option 3 will say ohm inverse centimeter square mole inverse. What is your answer? Ohm inverse centimeter square mole inverse. So what the option will take? You have to take option 3. So this is question number 26. See 27. The highest electrical conductivity of the following aqueous solution is. They are asking highest electrical conductivity. They given 0. All concentration is same. One is acetic acid. 0.1 molar acetic acid. Concentration is same. Next 0.1 molar chloroacetic acid. Chloroacetic acid. Next is 0.1 molar fluoroacetic acid. Fluoroacetic acid. Last one 0.1 molar difluoroacetic acid. Difluoroacetic acid. So concentration is same, but you can see here acetic acid, fluoroacetic acid, fluoroacetic acid, difluoroacetic acid. Which one having highest acidic nature? I will write this in K nature here. What is the formula of this one? Difluoroacetic acid is CF2CH. This is CF2CH COOH. This is CH2COOH. This is CH2COOH. This is CH3COOH. We can identify which one is strong gas among those. You know, more electronegativity increases, acidic nature increases. Here chlorine is there, but here only one chlorine and one fluorine. But here how many fluorines are there? 2 fluorines are there. So we write here CF2CH2COOH greater than FCH2COOH greater than ClCH2COOH greater than CH3COOH. Which is strong acid? Difluoroacetic acid is strong acid. It is having highest electrical conductivity. Okay. What is your answer? Your answer is option 4. So this is question number 27. Next we will see question number 28. See question number 28. Given L by R is equal to 0.5 centimeter inverse, R is equal to 50 ohm, L is equal to 1.0, the equivalent conductance of an electrolytic cell. They ask the equivalent conductivity. They given L by A and R resistance given. What is the formula for equivalent conductivity? Equivalent conductivity cap EQ is equal to A into 1000 by normal. If the values are given L by A, L by A is given 0.5 centimeter inverse. R is given 50 ohm and normally given 1.0. So we have to first find out J. After that we can find find out the K, then you can substitute the K value in this formula, you will get the equivalent conductivity. How can you identify K here? What is K here? K is conductivity. This is the inverse of the resistivity, or you can say the specific resistance only. K is equal to 1 by rho. So generally you know one formula what here, R is equal to rho into L by A formula here. L by A formula here. From this I will write here rho is equal to what I will write here, R into A by L I will write. Rho is equal to R into A by L. 1 by rho means what you will write? You will write L by R into A. 1 by rho is equal to what? L by R into A. So you see here L by A given, R is given. I will take this formula. So I will write 1 by rho value I want to find out here. So 1 by rho is equal to L by A into R. What is the L by A value given? L by A value given, this is 0.5 centimeter inverse by R value given here 50 ohm. How much? 50 ohm. So we will write this one. This I will write here, find by 500 into, this is centimeter inverse and this is ohm. So from this I will write 1 by 100. 1 by 100 means I write this is 10 power minus 2. This is centimeter inverse and ohm inverse I got. Clear? Now I want to substitute this 1 by rho value. K is what? 1 by rho. K value how much I got? So K is equal to 1 by rho. 1 by rho how much I got? 10 power minus 2. Substitute the values here. So equivalent conductivity is equal to, this is 10 power minus 2. I will write this one, centimeter inverse. Say ohm inverse means can I write yes into this is 1000. If you want to write, this is centimeter cube by normality 1. You multiply this one. So 10 power minus 10, what you get? 10. So centimeter inverse, this is centimeter cube, what you get? This is, yes, I am writing here, Siemann centimeter square mole inverse I got. So what is the equivalent conductivity for this question? 10 Siemann centimeter square. Gram unit you can write, gram per unit you write, because this equivalent conductivity gram unit, that was only. In place of Siemann you write what? Ohm inverse you write. So 10 ohm inverse centimeter square gram equivalent inverse. So what is your answer? Your answer is option 1. So the next question, question number 28. The equivalent conductance of 1 molar benzoic acid is 12.8 ohm inverse centimeter square. If the conductance of the benzoid ion and H plus ion are 42 and 288.42 ohm inverse centimeter square respectively, the degree of dissociation asked. Degree of dissociation alpha. Alpha you will write molar conductivity by limiting molar conductivity, or equivalent conductivity by equivalent conductivity. You know the formula. Here the equivalent conductance of 1 molar benzoic acid is given. So equivalent conductance already given for benzoic acid, that is 12.8 ohm inverse centimeter square. And one more is given, conductance of benzoid ion. What is the benzoid ion formula? C6H5, this is COO minus, and H plus also given. So C6H5 COO minus is given 42 and H plus is given here 288.42 ohm inverse centimeter square. So this is also ohm inverse centimeter square. Now what is the benzoic acid formula? Benzoic acid formula we have C6H5 right here. Limiting molar conductivity of C6H5 COOH is equal to lambda naught. This is C6H5 COO minus plus this is lambda naught H plus. According to the concept you are writing whole rasta. So what is the value of this one? This is 42 plus this is 288.42. So this is 288.42 and 42. Then you will get here, this is 10, 1, this is 13, 12% 13, you will get 330.4. 330.42. This is a ohm inverse centimeter. What it is? It is a limiting molar conductivity. What is alpha? Alpha is equal to, you know the form what it for? Molar equivalent conductivity. I can write this is equivalent conductivity. So I will write here equivalent conductivity by limiting equivalent conductivity. What is the equivalent conductivity we have? This is 288.42 by, you will get it here 330.42. This is alpha. What it is, alpha. So you will substitute the values. Then how much will you get here? 0.0387. 0.0387 will get. Now they are asking percentage of alpha is equal to 0.0387 into 100. You will get how much? 3.87. So 3.87, see the options, approximately they get 3.9. I will write this one 3.9%. 3.9%. So you will take option 2 for this question. Next, question number 30. Unit of ohm inverse used for. Options are given like this: molar conductivity, equivalent conductivity, specific conductivity, and conductivity. Molar conductivity units, Siemens centimeter square mole inverse, and equivalent conductivity units, Siemens centimeter square equivalent inverse. Here you can see option 3 and 4. 3 and 4 is given specific conductivity and conductivity, both are same out. So what are the units of conductivity? Generally, K is equal to 1 by rho. K is equal to what? 1 by rho. This is what conductivity, or you can say the specific conductance or conductance. But if you want to write the units generally from this, I will write here R is equal to rho into L by A. Suppose I am writing here. Then what I get here? Rho is equal to R into A by L. Suppose I am writing here 1 by rho. 1 by rho is what I get here? L by R into A. Then suppose you are taking meter here. This is R resistance is ohm. This is meter square. Then what you get? Ohm inverse and meter per second. Or you can say this one ohm inverse means what you can write Siemens by Siemens centimeter inverse or centimeter inverse you can write. So generally this is what the units of K means. K units 1 by rho. That means you will get Siemens centimeter inverse only. So this is the units of conductivity. Conductivity and specific conductance both are same, but they given ohm inverse. If they give ohm inverse, generally conductance G is equal to 1 by R. 1 by R means what you will write? Ohm inverse. So ohm inverse is a unit for what? Conductance, not for conductivity or specific conductance. So what you do one thing here, you can change 4 options. Option 4 you can change like this. In place of conductivity, you can write what? Conductance. Then you will get what units? You will get it ohm inverse. So this is question number 30. See question number 31. Galvanic cell converts. Galvanic cell convert chemical energy is converted into electrical energy. That is the option 1 is there. Question number 32. Hydrogen oxygen fuel cells are used to spacecraft to supply. So generally hydrogen H2O2 fuel cell, by combustion of, this is example for the fuel cell. It will produce hydrogen gas H2O along with this water. It will produce electricity is the main only. The byproduct water they may say produce the water. That water can be used for astronauts for the drinking purpose. Here you can say power and heat of the light, power for pressure, oxygen and water. We have 2 options are there. Here you can take 2 options for this question. Power of for pressure and water also. Here water also produced in this reaction, and one more power for the pressure. You will take option 2 and 4. This question number 32. Next you can see question number 33. Question number 33. The standard cell potential of Zn plus 2 equivalent Cu plus 2 equivalent Cu is 1.10. The maximum work done by this cell will be, I will write this cell representation Zn plus 2 equivalent. Sorted with we have this is Cu plus 2 equivalent Cu is. If you want to write the cell reaction, you write here Zn plus Cu2 plus equals to Zn plus 2 plus Cu. This is the cell reaction. In this cell reaction, how many electrons are changing? Zn is converted to Zn plus 2 and Cu plus 2 converted to Cu. What are the number of electrons changed? Number of electrons changed N is equal to 2 ohm. Then they ask here what? The maximum work done. Work done means critical energy. You will know delta Z naught is equal to minus NF T naught. What is the N value? N value of here 2 only minus 2 into this is 96500. And what is the E naught cell is given? E naught cell is given in this question 1.10 volts. How much? 1.10 volts. So E naught cell you will take this one 1.10 volts. So this minus is there. So what will be here? Minus this is 2.2 into 500. From this, okay, you multiply, then you get the answer. So approximately we get here minus 202.30 kilojoules. You multiply, then you can convert them into joules into kilojoules. So we get it minus 202.30 kilojoules. So this is question number 33. Next, 34. The relationship between the standard addition potential of the cell and equilibrium constant. This is the relation between E naught cell and equilibrium constant. Direct quotient formula, you know, these are already, E naught cell is equal to 0.059 by m into log s. This is the relation between E naught of the cell and equilibrium constant is. What answer you take? You take option 2. Next 35 question. Consider the galvanic cell ZnSO4 CSO4, that is Q plus is given, that you can take Cu. The reaction takes place at the cathode. ZnSO4 solid with this is CSO4 and Cu. They are asking reaction at cathode. You know this is anode. This is what cathode. At cathode what we have? Cu plus 2 convert into Cu, how the reaction? Cu plus 2 get into electrons, deposit what? Copper. What answer you take? You take option 2. This is galvanic cell, you know already. Next, question number 36. The cell reaction is given. What is that? Cu plus 2Ag plus implies 2. Cu plus 2 plus 2Ag. This is solid generally. This copper is solid here. Here copper plus 2 is aqueous. This is an aqueous. This is a solid. They are asking represent the cell. Represent the cell reaction. How can you write the cell reaction oxidation for anode, solid bridge, cathode? Here Cu converted to Cu plus 2. This is the oxidation? Yes. So you will write here Cu plus 2, this is solid and this is aqueous. And you can use what? Solid bridge. Then it is Ag plus aqueous and this Ag solid. What answer will take? Cu plus 2, Ag plus 2, what? Ag will take option 1 for this. Simple question, representation of the cell. Next step. Question number 37 we will see. Zn plus 2 anode, Cu plus 2 Cu cathode. What cell it is? What cell it is? Daniel cell or galvanic cell. So you will take option 2. Simply here see Zn plus 2. I will write this reaction like this. Zn plus 2 solid bridge Cu plus 2 Cu. What it is? It is the reaction takes place in. See the 8th question. The specific conductance of a solution is 0.2 mole inverse centimeter inverse and the conductivity is 0.04 ohm inverse. The cell constant they are asking. Specific conductance. Or you will say this is conductivity also is equal to 0.2 ohm inverse centimeter inverse. The next one given conductivity, that is not conductivity, that is conductance. That is conductance. Okay, specific conductance, or we can say this is conductivity. So conductance is given 0.04, which is ohm inverse. From this they are asking cell constant. What they are asking? Cell constant. So we have to get the relation between this specific conductance and the cell constant. So specific conductance A is equal to, I will write here G into T star. So this is conductivity of the specific conductance. This is specific conductance. G is conductance. G star cell constant. G star cell constant. Now G star is equal to K by Z. What is the K value? This is 0.2 ohm inverse centimeter inverse by 0.04 ohm inverse. This is cancelled. You will get here 5 centimeter inverse. 5 centimeter inverse. So this is the answer. So what answer will take? We will take option 3 for this question. Question number 39. You will see. If the conductance and the specific conductance of a solution is 1, the cell constant would be. Now we have the formula is there. Specific conductance is there, conductance is there. They are asking cell constant. I will get the same formula. This is the 39 question. So K is equal to G into E star. K value 1, G value 1. Then G star value how much? 1. How will you write? You will write here G star is equal to A by E. This is 1 by 1. That is equal to 1. What is the value? Option is 1. Now we will see question number 40. That question. E naught is equal to RT by MF into ln EQ. This is called Darmstadt equation. What equation? Darmstadt equation for the singular electrode. Question number 41 you will see. 4 alkyl metals A, B, C, D are having respectively the standard electrode potentials minus 3.05, minus 1.66, minus 0.40, and which one is more reactive? More reactive means more reduction potential value. Which one having more reduction potential value? That means in the sense more negative, that is A, that is minus 3.05. You will take direct reducing power question. You will take option A. Next, question number 42 you will see. Question number 42. Which of the following metals cannot evolve H2 from acids or H2O from its compounds? Which of the following metals cannot evolve H2 or H2? They can reaction with acid or water. The options are given: mercury, aluminum, lead, iron. So generally you know one concept: the metals which are present above the hydrogen electrode, they can displace hydrogen from the dilute acids. The metals which are present above the hydrogen electrode, those metals can displace hydrogen gas from the dilute acids or water. The below metals cannot displace hydrogen from the dilute acids. You will see aluminum, lead, iron. Aluminum, lead, iron, they can present above hydrogen. Above hydrogen in the electrochemical series. So they will displace hydrogen from the dilute acids. Which one is not displacing? That is mercury. You know what aluminum code? PSBC, EMA, Z, I, N, L, H. This is CH, A. You can see what is A here? Aluminum. L means what? Lead. T. Okay. And this is I means what? Iron. Aluminum, iron, lead. They will present above hydrogen electrode, so they can displace H2 from the dilute acid. But below metal, that is what? Mercury can be present below the hydrogen electrode. It does not displace H2 from the dilute acids or water. This question mainly based on electrochemical series reactivity. So what is your answer? Your answer is option 1. Yes, next you can see question number 43. Which of the following reactions are not possible? First option will say, what is the first option? Fe plus H2SO4. Fe plus H2SO4 gives rise to FeSO4 plus H2. See, iron is there. The liberate hydrogen gas from the dilute acids. This reaction is possible because hydrogen can be present below the iron, or you can say iron can be present above the hydrogen to displace hydrogen from the dilute acid. Now I discussed. Okay, so this reaction is possible. Second equation you can say copper plus silver nitrate. Copper plus silver nitrate gives rise to copper nitrate. Cu and O taken 2 times plus 2Ag. This is the question. So silver and copper is there. Among the silver and copper, which is more reactive? Copper is more reactive than silver. So copper displaces silver from its solutions. So then what is formed here? It will form a copper nitrate. So this is also a positive reaction. See, the next we have 2 KBr plus I2 gives rise to 2 Ki plus Br. So here I2 displaces the Br. You know the reactivity order of these hydrogens F2, Cl2, Br2 and I2. So Br2 displaces iodine, but iodine does not displace what? what? Br from the solution. You know this concept? Fluorine can displace chlorine, bromine, iodine. Chlorine displaces bromine, iodine. Bromine displaces only what? Iodine, but iodine does not displace bromine. So this reaction is not possible. Okay, what is your answer? You will take option 3. Which of the reaction is not possible means option 3 is not possible. Next you can say question number 44. See question number 44. When a rod of metal A is dipped in an aqueous solution of metal B, the concentration of the B plus 2 ion being 1 molar at 25 degrees Celsius, the standard electrode potentials of A plus 2A is minus 0.76 and B plus 2B is plus 0.34 volts. So they given A will gradually dissolve, B will deposit it on A, no reaction will occur, water will decompose into H2 and O2. I will write the first what the electrode potentials are given. They given A plus 2, A is equal to minus 0.76 volts. And one more is given B plus 2, B is given over there is plus 0.34 volts is given. 0.34 volts is given. So here which is the strongest oxidizing agent? B plus 2B is a strong oxidizing agent. Strong oxidizing agent. If you see the reaction, how the reaction takes place, I will write this equation A plus B plus 2 gives rise to, you will get here A plus 2 and B and B. So here B plus 2 in the form of aqueous solution, A plus 2 in the form of aqueous solution. This is A in the form of deposition. So B metal can be deposited what? A. So B is deposited. So which solution is deposited? It is deposited on A. So what is your answer? B will deposit it on A. So that answer will take option 2 is the right answer for this question. Now we'll see question number 45. Question number 45, the equivalent of reaction here. Zn plus 2 gain 2 electrons gives Zn, and the reduction, the standard potential of zinc is given here. Standard potential. Zinc is given how much? Minus 0.76 volts. Now the question asks here, zinc cannot displace from hydrogen from dilute acids. Zinc is a reducing agent. Zinc is a oxidizing agent. Zn plus 2 is a reducing agent. So you will take here electrode potential of zinc is given. So you know now this is Zn plus 2. Zn is given how much? This is minus 0.76 volts. So this is what here, this is the reduction potential only. So zinc has a greater tendency to oxidize. Zn has greater tendency to oxidize. It can access what? Reducing agent. It can access what? Reducing agent. So zinc acts as what? Zinc acts as a reducing agent. So this is question number 45. See level 2, exercise level 2 also completed. Once again a small topic is there, we have conductivity. So there is a small mistake we got in this conductivity units and all. This is there in episode 3. You just can check it. This side. Reaching that one again, I'm explaining this conductivity concept only. So what is this conductivity? Conductivity is inverse of resistivity. Conductivity is what? Inverse of resistivity, or you can say reciprocal of the resistivity of square. I will write here K is equal to 1 by rho. K is equal to 1 by rho. Generally, how will you get this units and all this I am writing here? What is resistance? Resistance R is equal to rho into L by A. Rho into L by A. From this I will write rho is equal to R into A by L. R into A by L. Suppose I want to write here 1 by rho. 1 by rho what I get here? I will write here of K I am writing K is equal to L by R into A. K is equal to L by R into A. So K is equal to what are the units of length? Meter. This is meter by resistance is what? Ohm. Area meter square area. So K is equal to here meter and meter square cancel. Then you will get ohm inverse and meter inverse. Ohm inverse and what? Meter inverse. But ohm inverse is equal to this is Simon involving here. Simon means you write what? Yes, you will write. So K is equal to this. You will write Simon meter per second. Generally, what are the units here? This is the assignment one. So normally we are using here K is equal to Simon centimeter per second. Simon centimeter per second. So this is the units of which one? K. What is K here? K is called conductivity. Is the inverse of the resistivity moment. Okay, just you can change this one like this. So finally we got the units of K what? Siemens and centimeter inverse. So next we will discuss AA, PM and lead questions from your material. So the lead questions, first question. The correct value of the EMF of cell is given by EMF of the cell is given by. They given here different options are given. First I will write this formula. Then you will choose which is the right answer for this question. EMF of the cell you write here E cell. Generally E cell is equal to oxidation potential at anode plus reduction potential at cathode. Oxidation potential at anode plus what? Reduction potential at cathode. This is the formula generally. So if you want to write here E cell is equal to E cell we are writing in a different manner. So I will write here E oxidation potential. E OP is what? E oxidation potential at anode plus E reduction potential. E reduction potential at cathode. If you want to convert this one also into oxidation potential, you know one formula. Oxidation potential is equal to minus reduction potential. From this you will write that E cell is equal to E oxidation potential at anode minus E. If you want to write here reduction potential becomes what here? Oxidation potential. From this I write reduction potential is equal to minus oxidation potential. E oxidation potential at cathode minus E oxidation potential at cathode. E oxidation potential at anode minus E oxidation potential at cathode. So this is the one formula and this is what? One more formula. You can see the first option we have. E pot cell is equal to E naught anode minus E reduction potential at cathode. It's not given. Second option you will see oxidation potential at anode plus oxidation potential reduction potential at cathode. This is the right answer. Third option you will see E cell is equal to reduction potential at anode plus reduction potential at what? Cathode. That is not given. And E cell is equal to E naught oxidation potential, E oxidation potential at anode minus E oxidation potential at what? Cathode. What is your answer? You will take both options. Means what will you take here? 3 and 2 and 4. 2 and 4. This is the direct question already given in the concept itself. And this is question number 2. The reduction potential of silver ions with the copper metal and the standard cell potential is 0.46 volts at 25 degrees Celsius. The value of the standard Gibbs frequency delta Z. First of all, you can write the reaction. What it is said for the reduction of silver ions with copper metal. Silver ions with copper metal. Okay, I will write this equation. Cu plus Ag plus gives rise to Cu plus 2 plus Ag. I will write here 2Ag plus and I will get here 2Ag. This is the reaction. Silver ions with copper. What are the N value? N value is 2. What is the formula? Standard frequency. What is the formula? Delta G naught is equal to minus NF E naught cell. N value 2. E naught cell how much given? 0.46 volts. So E naught cell is given 0.46 volts. F is equal to 965. Substitute the values. Delta Z naught is equal to minus 2 into this is 96500 into 0.46. So you will get here minus 89.0 kilograms. So this is the answer for this question number 2. Next question number 3. Question number 3. An increase in the electrical conductivity of a strong electrolyte with dilution mainly due to. You know the strong electrolytes. Strong electrolyte undergo complete dissociation. Strong electrolytes are there undergo complete dissociation. Strong electrolytes undergo complete dissociation. Suppose you can take suppose H2SO, suppose you are taking it dissociate to 2H plus and SO4 minus 2. Already discussed in the variation of the molar conductivity dilution for the strong electrolyte, weak electrolytes and all discussed but the dilution concept. So strong electrolytes are there and what happened, they undergo complete ionization. So degree of dissociation is 100%. Alpha value you can say 1 only. Clear? Now here what they ask here, the increase in the equivalent conductivity for the strong electrolyte is the dilution. Upon dilution generally, upon dilution what happened here, conductivity increases, specific conductance decreases, molar conductivity increases, equivalent conductance increases. So what is the reason they are asking? The reason is because of which one? Mobility, increase in the ionic mobility of the ions. Increase in the ionic mobility of ions. So what answer we will take? We will take option 1 for this question. Next we can see question number 4. So question number 4, what they are asking here, the electrode potentials, this question already discussed in the class itself. The electrode potentials for Cu plus 2 electron, I will write the first one here. Cu plus 2 gain 1 electron converted into, this is Cu plus, and one more equation we have Cu plus gain electron converted into Cu. Okay, the SL potential is given. They given E0 cell. I will take this one E1. I will take this is plus 0.15. Suppose I will take this is E2. That we have plus 0.50. Plus 0.50. The value of E0 cell they ask here. The value of what they ask here? E0 of Cu plus 2 Cu they ask. E0 of Cu plus 2 Cu means what you can get here. If you are taking Cu plus 2 converted into Cu, if you write this equation, what is the E0 cell task? What is the E0 cell task? Already the same question discussed, you will get it. The answer is 0.325 volts. Again, I have explained the same question. So how will you write this? How will you find out the cell potential if they given 2 or more cells? So in this case, we will write down formula here: delta G1, delta G2, delta G3, like this formula. So you want to get any one equation, you can combine other two equations. Suppose I am taking equation 1 and equation 2. So equation 1, what is the equation? This is Cu plus 2, gain 1 electron, convert into Cu plus. And the second equation, Cu plus, gain electron, convert into Cu. If you write the overall reaction, what you will get? Cu plus cancel. Yes, what you will get? This is Cu plus 2 electron, convert into what? This is the reaction expression. So we are getting this equation or not? How we are getting? By combining these two. So by combining these two, we will get it. The third equation. How we can write here? We will write the expression like this. So this one, this one. Okay. Now I am writing here delta Z3 is equal to delta Z1 plus delta Z. You know what is delta Z generally? Delta Z, suppose you are taking minus ENF E0. So in this case, what are the value? How many electrons are lost here? Here n is 1. Here also what? Here n is 1. Here what is n? En is equal to. N is equal to what? 2. If you write this one, what will you get here? Delta Z is what here? Minus En3. E3 not cell. E3. F is equal to. This is minus N1. E1 not F plus. I can take this one plus. Let this one minus minus of minus is there, plus I will write this one minus what you can get minus N2 E2 not F. What is cancelled on both sides? F is cancelled and you can take the negative as a what? Common in both sides. Then what I am writing here? I will write N3 E3 not is equal to N1 E1 not plus we will get N2 E2 not. Now I write here E3 not is equal to N1 E1 not plus N2 E2 not by En. What is the N1 value? Here 1 E1 not 0.15. This is 1 into 0.15 plus this is 1 into 0.50 by 2 only. You will get here 0.65 by 2. This is 0.65. Okay, 0.5, 1.5. 0.65 by 2. What do you get? This is 3, 2, and 5. So what is the E3 not value? 0.325. So you will take what the answer. Your answer is option 2. See the next question, question number 5. The standard reduction potentials of Sn plus 4, Sn plus 2 plus 0.15 volts and Cr plus 3, Cr is given minus 0.74 volts. If the two couples in the standard cell states are connected to make a cell, the cell potential would be asking. What the asking? Cell potential means that is EMF of the cell. Or you can say here IV cell, IV naught cell is equal to what you can write E naught cathode minus E naught anode. Cathode means always I told you highest value always tells about cathode. That is 0.15, that is plus 0.15 minus of minus this is 0.74. So 0.15 plus 0.74. 0.15, 0.74, what will get one? Plus 0.89 volts. So what is your answer? Your answer is option 4. Question number 6. The standard output potentials of the three metals X, Y, Z minus 1.2 X, Y, Z minus 1.2 plus 0.5 minus 3.0 volts. So they are asking the reducing power of these metals. More the negative, more the reducing power, whatever answer. Z is greater than, X is greater than Y. Next question number 7. If the A naught is like this question number 7. 7th question will say, if the E naught of the cell is given has a negative value, I will write here, E naught cell is given negative. If the E naught cell is given negative, which of the following will give the correct relationship between delta G naught and K equivalent? You know one formula, delta G naught is equal to minus NF E naught cell, minus NF E naught cell. So here E naught cell is negative given. E naught cell is negative, the cell reaction does not express. If E naught cell is negative, what is the delta Z value? If E naught cell is what? Negative, then what? Delta Z become what here? Positive. Means delta Z naught greater than 0. Delta Z naught what? Greater than 0. If you want to take the reverse reaction, if you want to take delta Z is negative, then E cell is what? Positive. Delta Z negative, that is the spontaneous process. For spontaneous process, delta Z value negative. So you make this E naught cell is negative, the delta Z becomes what? Positive. The delta Z naught value what? Greater than 0. So you know one formula we have, delta Z naught is equal to minus 2.303 RT log K, or you can say we will take minus 2.303 RT L and K. You can take that K in the form of equivalent only. If the delta Z greater than 0, already I give one table for you. If delta Z naught greater than 0, that K equivalent is what? Less than 1 only. So what is your answer? The delta Z greater than 0 and K less than 1. So your answer is option 1. Now, question number 8. Let's see. The standard reduction potentials of the half cells are given. Okay, from the given information, they are asking the strongest and oxidizing and reducing agent from this equation they are asking. First one is given F2. I already said equation here. F2 plus 2F electrons equals to 2F minus. This E naught is equal to plus 2.85. Next one Cl2. Cl2 2 electrons. This is 2Cl minus. E naught is given plus 1.36. Next we have Br2. Br2 plus 2 electrons equals to 2 Br minus. E naught is equal to plus 1.06 volts. Next is the last one. I2 plus 2 electrons gives rise to 2I minus. This E naught is equal to plus 0.58. Now what are the question they ask here? The strongest oxidizing and reducing agent. What are the strongest oxidizing? Positive value, more the positive value. Fluorine to bromine, which one has highest value? This is plus 2.85 is the highest value. So this is the strongest oxidizing agent. Among those, which one is the least? Least means what? Fluorine, chlorine, bromine, iodine. Iodine is the least. So iodine is what? Reducing agent. Fluorine is what? Oxidizing agent. So what is your answer? So your answer is option 1. That is what? Strongest oxidizing agent is what? Fluorine. And reducing agent is what? Iodine. So this is the answer for this question. And question number 9, you will see. Question number 9. Limiting molar conductivity of NH4OH. This is the contrast application. So how you will get it? Limiting molar conductivity of NH4OH. Limiting molar conductivity of NH4OH you will get. What are the expressions are given? You see. I will take the first option. Suppose you can see what you will get, man. First option you will see NH4OH, NH4OH, Cl and HCl. NH4 cancel. Cl minus is cancel. You will get water. That is not right answer. See the second one. What is the second one? The limiting molar conductivity of NH4OH. Okay, I write that is equal to I write here. Limiting molar conductivity of NH4Cl plus molar conductivity of NaOH minus molar conductivity of NaCl. If you write this one, what you will get? You will get a lambda naught NH4 plus and lambda naught Cl minus. This is lambda naught Na plus. This is lambda naught OH minus. This is lambda naught Na plus minus lambda naught Cl minus. What is cancel? Lambda naught Na plus lambda Na plus cancel. Cl minus cancel. Then you will get it. Lambda naught NH4 plus lambda naught OH minus. So this is what? This is the limiting molar conductivity of which one? NH4OH. NH4OH. So what expression you will take? You will take option 2 is the right answer for this question. See question number 10. This is also limiting molar conductivity, that is molar conductivity of at one dilution NaCl, HCl, CH3, CO, Na are 126.4, 425.9 and 91.0 Siemens centimeter square mole inverse respectively. The molar conductivity for acetic acid. This question only we discussed in the class itself. So just I'm writing the formula. You can use this and you will solve this question. So this is limiting molar conductivity of what is required for us. What is required is acetic acid. Limiting molar conductivity of acetic acid. I will write limiting molar conductivity of CH3CO by Na. CH3CO by Na minus limiting molar conductivity of NaCl minus limiting molar conductivity of HCl. What is cancel here? Cl minus cancel, Na plus cancel, then you will get this limiting molar conductivity of CH3CO. What is the statement? Instead we have 91 minus NaCl 126.4 plus HCl 91. Limiting molar conductivity of NaCl how much? First one is given NaCl, that is 126.4 and sodium acetate 91, that is HCl how much? We have 425.9. So altogether we will get 390.5 Siemens centimeter square mole inverse. A direct question is. Next question number 11. A button cell is in the watches as a functioning, button cell is the primary cell. The given cell reaction, that is Zn plus 2 electrons gain Zn solid, E naught cell given minus 0.76 and Ag2O plus H2O plus 2 electrons gives rise to 2Ag plus 2OH minus, that E naught cell is given 0.34 volts. They are asking cell potential. What is cell potential? E naught cell. I already told you. E naught cathode minus E naught anode. What are the cathode highest value? What are the highest value among those? That is 0.34 plus 0.34. This is minus of minus 0.76. So this is 0.34 plus 0.76. What is the value? 1.10. We will take option 3. Next question number 12. 25 degrees Celsius, the molar conductance of 0.1 molar aqueous solution of ammonium hydroxide is 9.54 ohm inverse centimeter square mole inverse. At infinite dilution, its molar conductance is 238 ohm inverse centimeter square mole inverse. The degree of ionization at this temperature, they are asking alpha. Alpha is equal to, what is the formula? molar conductivity by limiting molar conductivity. What is the molar conductivity is given? That is first one is given, that is 9.54. Don't confuse concentration also given, don't use that one. And infinite dilation is what? That is limiting molar conductance. That is given 238. So what you will get it? You will solve this one. What you will get? 9.454 by 2 will get, that is 0.00400. 0.00408. So then you can ask the percentage of alpha. Multiply this one with what? 100. 0.00408 into 100. What will you get? You will get here 4.08. 4.08. So you will solve this one. You will get it 4 into 100. You will get it how much percent? 4.08%. Alpha is equal to how much? Percentage of alpha is equal to, you will get 4.8%. Next step. See the next question, question number 13. The hydrogen gas electrode is made by dipping the wire in a solution of HCl, pH is equal to 10. By passing hydrogen gas around the platinum wire at 1 atmosphere, the oxidation potential of electrode would be. This question is related to hydrogen electrode, that is standard hydrogen electrode. You know, standard hydrogen electrode can act as an anode and cathode. So, what are the information given? I am writing here. pH of HCl is given 10. pH is 10 only. If you want to write concentration of H+, what you will get? 10 power minus 10. We have direct formulas are there. ECl is equal to 0.059 into pH, that is given if they ask the oxidation potential. One more formula we have, ECl is equal to minus 0.05 into pH if they ask the reduction potential. In this question they are asking what oxidation potential, you can use this formula. And what you will get now? You will get ECl is equal to 0.059. What the pH is given? 10. What is your answer? 0.59 is the answer. So you will take option 1 for this question. Next question number 14. MnO4 minus 0.1 mole of MnO4 minus is oxidized by a quantity of electricity required to complete to oxidize MnO4 minus to MnO4 minus. MnO4 minus to converted to MnO4 minus. You know what is the oxidation state of manganese here? Plus 7. In this case, how much you will get? X minus 8 is equal to minus 2. So x equal to minus 2 plus 8. So you will get x equal to what? Plus 6. So here plus 6 is there. Here what? Plus 7 is there. The change in number of electrons, how much here? The change in number of electrons here, 1 only. 1 electron, you will write here 1 farad. But here they given 0.1 mole. 0.1 mole. If you take 1 mole of MnO4 minus, how much farads is required? 1 farad. 1 farad value, that is 96500 coulombs. If you want to take 0.1 mole, so 0.1 mole of MnO4 minus 2 require what? This is 0.1 into 96.00 coulombs. Then what you will get? You will get that 9650 coulombs. So what is your answer? Your answer is option 3. Next, 15th question. A device that converts energy by combustion of fuels like hydrogen, methane directly into electrical energy. This is known as what? Fuel cell. Already know this one. 16th question. An aqueous solution of which of the following compounds is the best conductor of electric current? Best conductor of electric current, that is strong electrolyte. Ammonia, it's not. Fructose, weak electrolyte. Acetic acid, fructose is a non-electrolyte. Acetic acid is a weak electrolyte. Hydrochloric acid is what? Strong electrolyte. Is a best conductor of electricity. So your answer is option 4. See the next question, question number 17. In the electrochemical cell, ZnSO4 concentration is given 0.01 and CSO4 Cu concentration 1.0. The EMF of the cell is E1. When the concentration changes to Zn is 1.0, copper sulfate is 0.01. The EMF changes to E2. They are asking what is the relation between E1 and E2. The first one I given here, ZnSO4, the concentration is given 0.01. So on to which copper sulfate 1.0 molar. This is copper. The EMF of the cell is E1. The second ZnSO4, the concentration of ZnSO4 changes to 1.0 m salt bridge, and the concentration of copper sulfate is 0.01. 0.01 Cu. The EMF of the cell is E2. They are asking what is the relation between E1 and E2. Same question discussed in the class. You will get the answer. What is the answer you will get? E1 greater than E2. That I already given one of the trick for you. If the concentration of copper is more, E cell is increases. If the concentration of copper is less, E cell is decreases. So here concentration is 1.0, here concentration is 0.01. Which one having highest value means E1 having highest value, we will get a direct answer. Otherwise, how we can apply? We can use the Laplace equation. E cell is equal to E naught cell minus 0.059 n into log you will write the product reactor. So this is E naught cell, this is we will take E1 cell minus 0.059 by 2 because there is a 2 electron set is there. If you want to see the reaction, how will you get here? Zn plus CuSO4 gives rise to ZnSO4 plus Cu, this is plus 2. Here this is plus 2, 0. So this you will write here log ZnSO4. What is the concentration of ZnSO4? 0.01 by this is copper concentration 0.1. So you will get a E naught cell minus 0.059 by 2 into this is log of 1 into 10 power minus. You will get here E naught cell minus 0.059 by 2. This we will write minus 2 into log 10. So 2 to cancel, here minus into minus plus. So you will get a E naught cell plus 0.059 log 10 value 1. So this is what? This is E1 cell. And one more they are asking E naught E2 cell. How will you write E2 cell? So I will write E2 cell is equal to E naught cell minus 0.059 by 2 I am writing directly. Concentrations you can see. This is log of the concentration of the CuSO4. Concentration of CuSO4 0.01 and ZnSO4 1 we will get here 1 by 0.01. So this you can write E naught cell minus 0.059 by 2 into this you will write 1 by 1 into 10 power minus 2. So 10 power minus 2 becomes 10 power 2 I write here E naught cell minus 0.059 by 2 into this is log 1 into 10 square 10 power 2. E naught cell minus 0.059 by 2 into this is 2 into log 10. With 2 to cancel, you will get E naught cell minus 0.059. So this is what? This is E2 cell. So here E1 cell plus 0.059, E2 cell, E naught cell minus 0.059. What is the relation? The relation between these two is what? E1 is greater than E2. We got it first. So you will take option. Option 2 is the right answer for this question. Consider the change in operation state of the bromine corresponding in a different EMF value shown below. BrO4 minus gives rise to Br minus 3. The cell potential is given on the arrow 1.82. BrO minus to HBrO that is 1.5. HBrO to Br2 that is 1.595. Br2 to Br minus that is given 1.065. They are asking which of the species undergoing this proportionation reaction. So what is this proportionation reaction? If the same element undergo both oxidation and reduction, that is called as disproportionation reaction. That is the definition of it. I will write these conversions. So the conversions BrO4 minus converted to BrO3 minus. I will write here E1 naught cell. How much given? 1.82 volts. Second we see BrO3 minus converted to HBRO. So this is E2 not cell given 1.5 volts. Next HBRO gives rise to BR2. This will write V naught cell is equal to 1.595. Next last conversion, BR2 converted into BR minus, you will take E naught plus cell is equal to 1.065 volts. So in each case I want to write the operation state of domain. This I write here plus 7, here you will get plus 5, this is plus 5, plus 1, this is the plus 1, 0, 0 to minus 1. So this is the conversion they given on. So from this what I want to find out, I want to find out the E naught cell for the, by taking two equations only. This I will take one set, this I will take the second set, this I will take the third set. I want to take here first one E1 dash. I'll take here E1 dash is equal to, I will get here E2 naught minus E1 naught cell. What are the E2 naught value we have? E2 naught value we have 1.5. This is 1.82. What will we get here? Minus 0.32 volts will be get. Minus 0.32 volts. So in this reaction, what will happen? If you combine these two, what is cancelled here? BrO3 minus BrO3 minus cancel. What will you get here? BrO4 minus converted into HBrO. In this case, if you want to find out here E2 naught cell. So E2 naught cell means this. What you can take here? E3 minus E2. You will take here E3 naught minus what? E2. So E3 means this is 1.595 and this is what? 1.5 volts. So what you will get here? You will get here plus 0.095. This is the plus 0.095. Here combining this, what is cancelled here? HBrO cancel. In this case, what you will get? BrO3 minus converted into what? BR. So third case we will see. What is the third case here? This is E3 naught cell. E4 minus E3. E3 naught cell. Okay, now E2 dash naught cell. E3 naught cell is equal to, I will write here E4 naught minus E3 naught. This is what now? 1.065 minus this is 1.595. So what the value here? Here minus 0.529 volts. By comparing this, what do you get? Here E naught cell value negative. This reaction is not feasible. Here E naught cell value is 1 negative. This reaction is also not feasible. So which reaction is feasible here? This third, you can say here BrO3 minus to HBrO. HBrO to what here? BrO minus. So here HBrO acts as what? HBrO undergo both oxidation and reduction. So it is a disproportionation reaction. Same element undergo both oxidation and what? Reduction. So these two reactions not visible only. This reaction is visible. From this what you can say? HBrO undergo what? Disproportionation reaction. So this is a objective questions on electrochemistry. So all the exercises level 1, level 2 and 8 APMT questions also complete.